The James Webb Space Telescope, also known as Webb or JWST, is a scientific trailblazer that has revealed amazing details about stars, planets, galaxies, and other fascinating cosmic phenomena. In addition to setting new standards for scientific excitement, Webb is hailed as the venerable Hubble Space Telescope's replacement. Individuals from all around the world are exchanging photos and using raw data to create fresh insights. 1 year has passed since the formidable James Webb Space Telescope unveiled its first ever historic image of the universe, shocking astronomers all across the world with its extraordinary detail. Its most recent finding, however, is a horrifying picture of the universe that we have never seen before. What has been found thus far by the James Webb Space Telescope? Is it posing more questions than it answers for scientists? Join us as we explore how the James Webb Space Telescope captures the most terrifying image ever seen in history. The successor to the Hubble telescope unveiled new information about star formation, galaxy mergers, and the early cosmos just 1 month after the initial photos were released. The pictures were breathtaking, revealing the universe in astounding detail. Since then, the number of discoveries has skyrocketed, providing scientists with an enormous data treasure mine. James Webb Space Telescope observations of cosmic tarantulas, record-breaking space smoke, stars on the verge of supernova explosions, and other incredible celestial objects have been documented. This satellite observatory's cutting-edge technology allows us to peer farther into space than ever before, revealing previously unknown details about the cosmos. A new era in astronomy has dawned thanks to the photos, which can be so detailed. To commemorate the first year of the James Webb Space Telescope's operation, NASA released a picture that shows a tiny star-forming area in the Rho-Ophiuchi cloud complex. The picture shows jets erupting from newborn stars as cosmic dust clouds of various colors collide. Molecular hydrogen makes up the red dust, and the presence of a circumstellar disk casts a shadow on a few stars, suggesting the possibility of planet formation. According to NASA, this stellar nursery is tiny and peaceful compared to others, even though the picture may show cosmic mayhem. Many of the young stars in this area are about the size of our Sun or even smaller, making it the nearest star-forming region to Earth. This picture was captured by the main camera of the observatory, the Webb Space Telescope's near-infrared camera, which captures cosmic images in 2 distinct infrared spectrums simultaneously. Furthermore, the Space Telescope has improved our knowledge of exoplanets, or worlds that orbit stars other than our Sun. James Webb is particularly good at looking at large, faraway galaxies. The satellite observatory discovered its first exoplanet, LHS 475b, at the beginning of 2023. The planet is 41 light-years distant and has a diameter comparable to Earth's. James Webb, according to NASA, is the sole operational telescope capable of classifying the atmosphere of Earth-sized exoplanets. According to the scientists in charge of the study team that made the discovery, the findings demonstrated how precise the telescope was, and rocky exoplanets are now a new frontier for astronomers to explore. After that, the James Webb Telescope found proof of long-gone galaxies that, from a theoretical standpoint, shouldn't have existed. Ivo Lab of Swinburne University and his worldwide astronomical team have found 6 enormous old galaxies called universe breakers, and they have the potential to completely change the way we think about space. These massive galaxies may have come into existence between 500 and 700 million years after the Big Bang, according to the researchers' results earlier this year. The telescope's infrared sensors detected them, and through the use of these instruments, we are able to glimpse back in time around 13.5 billion years when stars and galaxies were much older. The enormous vastness of the universe breakers has left scientists bewildered. Galaxies in the early universe should have been 10 to 100 times smaller than that. Their calculations indicate that these 6 objects may be billions of times heavier than our Sun. The sum of all the stars in one galaxy might be 100 billion times heavier than our Sun. Does the thought of trying to understand something so massive give you the willies? Even though the majority of galaxies during this period are relatively tiny and are just expanding ever so slightly, some monsters reach adulthood far more quickly than others. It is unclear what would cause this or how it would function. Penn State University astronomy and astrophysics assistant professor and study co-author Joel Leja expressed his astonishment at the discovery of a new category of objects formed at the Big Bang. The discovery that the development of huge galaxies started at the very beginning of the universe's history challenges many of our previously held beliefs about the state of science. It seems our discovery is so out of the ordinary that it poses challenges to the scientific community. It throws into doubt the entire scenario of how galaxies formed in the early universe. Way more massive than anyone expected describes these objects.
All galaxies in the range are considered babies since they are still in the process of formation.
However, galaxies that are as old as our own have been found in the early cosmos, which was previously thought to be its beginning. Spectrometry, which separates light into its component wavelengths to enable more accurate distance measurements, is still required to validate the results, which have scientists scratching their heads. There are only a handful of recently found objects for which distance and mass have been verified. If the data is accurate, galaxy creation had to have been considerably more efficient and rapid than what is now thought. The fact that spectra corroborated our standard operating systems-based inferences from the visuals is promising. For years, scientists have sought to decipher cosmic history. Nevertheless, a single piece of machinery may hold the key. Observations of space and time have long piqued the curiosity of scientists, so it is not surprising that conflicting facts presented by telescopes might lead to a lack of clarity. At this point, cosmologist Dr. Katie Mack has chosen to offer her insights into the matter to explain how this could be occurring. She pointed out that the JWST has been providing evidence of galaxies that seem to have originated or matured much earlier than what scientists had anticipated from their models. Do not worry, though. As Mack pointed out, the telescope is capturing images of galaxies over 13 billion light-years away, and they are somewhat blurry. It seems like there hasn't even been enough time since the Big Bang for these big galaxies to have formed, according to the dates that cosmologists have been receiving from the telescope. Many in the field were concerned that this casts doubt on various theories, including dark matter and the Big Bang. But we should go further into the evidence to find out for sure. The telescope captures breathtaking views of close nebulae, but fuzzy little dots when it comes to faraway galaxies. The reason is that different colors are affected by different parts of the light spectrum. The Webb telescope can detect light from a source in two different ways. It may utilize a spectrum by spreading out the light with a spectrograph, which works a bit like a prism, and examining the brightness of each color, or it can use filters that block all but a select range of colors. They can then calculate the redshift of the galaxy by comparing this data with spectra predicted for galaxies with the same characteristics. What this redshift informs us is the exact instant in cosmic history that we are viewing it. It turns out that many galaxies have an excess of stars or stars that were too young when they would have lived according to comparisons of models. There are a number of possible explanations for this. The photometric readings might have been off because of problems with the telescope's calibration. Alternatively, they may have been observing a cluster of galaxies that is not representative of the norm or extremely tiny areas of the sky. Another possible explanation is that galaxy spectrum models are designed for closer galaxies, which don't work well with galaxies further away. On the other hand, cosmologists would face the thrilling prospect of having to rethink cosmic evolution if those galaxies are indeed extremely large and earlier estimations were incorrect. Wouldn't you agree? But it's hardly the only area where scientists have fallen short despite technological progress. Planets that are actually too large to exist have experts very perplexed, and none more so than the finding of a planet that is deemed too massive for its sun. This has prompted a re-evaluation of our collective understanding of planet creation and solar system architecture, as well as the models developed by astronomers. In the aftermath, a planet that is 13 times as huge as Earth has been found, according to research out of Penn State. Legend has it that this planet is in a planetary system around the ultra-cool star LHS 3D154, a star that is 9 times less massive than our Sun. According to a news statement, the dwarf star has a mass ratio 100 times higher than Earth's ratio to the Sun. Prior to recently witnessing it for themselves, scientists did not believe such a scenario was feasible. But new evidence shows that the largest planet in our solar system is really orbiting one of the universe's smallest and coolest stars, an ultra-cool dwarf. We still know very little about the cosmos, and this finding proves it even more. A planet of this mass orbiting a star with such a low mass defies our expectations. These stars may have originated in massive gas and dust clouds. Planets may arise from the gas and dust that remain in the disk of material around the newborn star. After this, it is not anticipated that the planet-forming disk surrounding the low-mass star LHS 3D154 contains sufficient solid mass to produce this planet. However, it exists. Thus, we must now reconsider our theories regarding stellar and planetary formation. A good analogy would be to compare the star to a campfire. In order to maintain your body temperature, you must get nearer to the fire as its temperature decreases. Planets are no different. Planets that want to be hot enough to support liquid water must be closer to stars with lower temperatures. If a planet is in a tight enough orbit around an ultra-cool star, we can see the tug of the planet on the star's light, or speck, which causes a tiny shift in the star's color. On the other hand, look up into the sky. A new breathtaking image of the ice giant Uranus, featuring nearly all of its dusty rings which had previously been difficult to photograph, has been snapped by the James Webb Space Telescope. For the fainter rings, which have only been seen by the Cosmic Discovery 2 and W. Keck Observatory on Mauna Kea in Hawaii spacecraft thus far, the picture is a breathtaking demonstration of the telescope's sensitivity. Uranus, which is 12 billion miles from the Sun, has 13 recognized rings, 11 of which are shown in the breathtaking new image from the Webb Space Telescope. In contrast to Saturn's horizontal rings, this planet's peculiar side tilt makes its rings appear vertical. The 2 outer rings were not identified until the 1986 flyby of the Cosmic Discovery 2 spacecraft because their dusty makeup made them less visible and more difficult to photograph. The 9 major rings were already known about before then. In 2007, photos captured by the NASA Hubble Space Telescope revealed 2 more fainter outer rings that are not visible in the Webb photographs. Webb has the potential to catch them, according to scientists. A planet ring system provides valuable information regarding the planet's genesis and origin. Uranus is an extremely peculiar globe with its slanted orbit and absence of interior heat. Therefore, any information regarding its past would be very appreciated. The peculiar atmospheric makeup of the massive gas-based planet Uranus is something that scientists are hoping the telescope can shed light on, since no other telescope of this scale has ever been able to see infrared light. The JWST allows us to examine Neptune and Uranus through a wholly novel lens. Telescopes that use visible light, such as Hubble, are unable to observe infrared wavelengths. Yet, infrared imaging can reveal previously unseen depths and features. Moreover, extraordinary footage of a star nearing death has been acquired by the James Webb Space Telescope. With JWST's late 2021 deployment, the fading star image is among the first flawlessly recorded events of its kind. The enormous dying star Wolf Rayet 124 was captured on film by the telescope's infrared lens as it ejected gas and dust into space,